From the first known composed melody, the Hurrian songs found in Syria, to the latest pop track, people love writing, playing, and listening to music. It's a fundamental part of what makes us human. And for decades, researchers have explored the relationship between the art of music and the human brain. Like this one study published in Nature Neuroscience that discovered dopamine releases are highest when a song reaches its emotional peak. Now, with advancements in AI and large language models, researchers are able to discover even more.
Yeah, our most recent paper shows how we can reconstruct music from brain scans using deep neural networks.
In the brain, cerebral blood flow and neural activity are connected, meaning that an fMRI scanner can indirectly pick up signals from brain activity by detecting changes in blood flow.
When someone is listening to the music, our auditory cortex, which is here, is strongly activating. And this activity is different depending on the music types. For example, when we are listening to the classic, the activity within the auditory cortex is different from a pop music or rock music.
Use Lab and the Google research team took these signals and condensed them into the semantic 128-dimensional music embedding space of Mulan, a joint embedding of music audio and natural language. The music generation model, MusicLM, was then used to reconstruct the music. So when a participant listened to a country song, the reconstruction sounded like this.
The recent developments in the machine learning domain have certainly helped the neuroscience domain be able to decode really low-dimensional representations of music or images, whatever it may be, into something that we humans then can easily process, like an actual image or an actual music clip.
The paper led to a surprising discovery, too. It was discovered that high-level semantic information, the genre, style, and mood, and the lower-level information of music are processed in the same region of the auditory cortex. They're not segregated. Here's you again to tell us why that was a surprise.
When I did the similar study in the visual cortex, the higher order and lower order information are segregated within our visual cortex. So these types of the difference between the auditory and the image processing are interesting as a neuroscientist. So our next step is to discover why such a difference emerged.
So, can AI decode the music you're listening to? Yes. Thanks to researchers like Timo and you, it can.
Another part that made this project really fun for me was collaborating with people outside of Google that have an entirely different background. And this was just overall a really fruitful collaboration.